Now we are going to discuss about a solenoid. What is meant by a solenoid? It is a coil of many circular turns of insulated copper wire which is wrapped closely in the form of a cylinder is called solenoid. So it is a coil of number of turns, isn't it? So similar to a circular loop, this solenoid also produces magnetic field when the current passes through it. But the magnetic field or field lines produced by a solenoid is similar to a bar magnet. We already discussed about the properties of magnetic field lines produced by a bar magnet. So the solenoid also produces magnetic field lines which are similar to a bar magnet. So the properties of magnetic field lines produced by a solenoid are, they are in the form of closed continuous curves. They emerge from the north pole and emerge at the south pole. Inside the solenoid, they are from south to north. Inside the solenoid, they move from south to north. And inside the solenoid, the magnetic field lines are parallel to each other. So, magnetic field is uniform inside the solenoid. Okay, no field lines can intersect each other. So, all these are similar to a bar magnet. But when the current is switched off, this solenoid loses its magnetism or it loses its magnetic strength. Okay, so when the current is switched off, it loses its magnetic strength, which is entirely different from a bar magnet. And we can increase the strength of this solenoid by increasing the number of turns. When we increase the number of turns, the number of magnetic field lines produced by each turn also increases. So it will add it up. So magnetic field strength also increases. Another way to increase the strength of the solenoid is increase the current in the circuit. When the current increases, the magnetic field strength produced by a solenoid also increases. Next, we can insert a soft iron core inside the solenoid so that it can be magnetized when the current passes through this solenoid. So the magnet so formed is known as electromagnet. And hence the strength of this solenoid, magnetic field produced by solenoid also increases. So these are the ways to increase the strength of the magnetic field produced by a solenoid. First of all, increase the number of turns. Second one, increase the current in the circuit. And third one, insert a soft iron core inside the solenoid. Okay, and here also we can detect the north pole and south pole based on the direction of current in the solenoid. That means the polarity at the ends of the solenoid depends upon the direction of current. If the current in a phase is in clockwise direction, then that end has south polarity. If the current in the phase is in anti-clockwise direction, then that end has north polarity. So the polarity of a solenoid can be interchanged by reversing the direction of current. The polarity of the solenoid or electromagnet also can be interchanged by changing or by reversing the direction of current. So now we discussed about a solenoid and then electromagnet. If a soft iron core is inserted inside a solenoid, it can be magnetized. So the magnet so formed is called electromagnet, right? So what are the differences between electromagnet and a permanent magnet? You already know bar magnet. So what are the differences between electromagnet and permanent magnet? Find it out. Okay.